It was a profound moment. During the night, the Andromeda Nebula transformed into the Andromeda Galaxy. For years, our knowledge of the Andromeda Galaxy was limited to ground-based observations. However, with the advancement of technology and the delivery of the James Webb Space Telescope, our understanding has grown immeasurably. Now things are about to change dramatically, as the James Webb Space Telescope has detected alarming signals coming from the Andromeda Galaxy. These figures sent shockwaves through the scientific community, leaving astronomers both excited and curious. But what exactly do these signals mean? And most importantly, why do they cause such confusion among astronomers? Join us as we delve into the mystery. Just 2 minutes ago, the James Webb Telescope suddenly shut down after receiving these alarm signals from Andromeda. We used to see only a fraction of the universe outside our eyes. Astronomers once believed that the Milky Way was the entire universe. This misconception was due to the limited technology available to observe different galaxies and individual stars. However, everything changed when we discovered the Andromeda Galaxy. This was our first hint that the universe extends far beyond the Milky Way. The journey began in the 17th century when Galileo Galilei's pioneering work with telescopes revealed the true nature of the Milky Way. He saw that the Milky Way was made up of countless stars, challenging the prevailing notion of its singular importance. Everything changed again in the 1920s when Edwin Hubble discovered distant objects beyond the Milky Way. Using the Hooker telescope, Hubble discovered that those celestial bodies moving through space are galaxies other than the Milky Way. One of those galaxies was the Andromeda Galaxy, or M31. Although this was the first time we saw the Andromeda Galaxy through a telescope, it was discovered in the 11th century by the Persian astronomer Abd al-Rahman al-Sufi. Advances in technology in the 20th century allowed astronomers to see and understand the true nature and essence of Andromeda. Andromeda is a nebulous cloud consisting of a large galaxy of stars similar to the Milky Way. Our cosmic neighbor is about 2.5 million light-years away from the Milky Way. Since its discovery, our methods of observing Andromeda have advanced significantly. We have moved from terrestrial observations with telescopes to space observatories such as Hubble and the James Webb Space Telescope. Each technological leap has taken us to new heights, helping us unlock the secrets of the Andromeda Galaxy. We now have more data and information about its composition and structure, making Andromeda a benchmark for the study of galaxy formation and growth. It shed more light on the larger principles of how the universe works. Scientists believe that to better understand our universe and the Milky Way, we need to study the relationship between Andromeda and the Milky Way. This is especially true because both galaxies collide every 4 billion years. As exploration and research progressed, the James Webb Telescope recently detected a disturbing signal from Andromeda. This alarming signal is puzzling scientists around the world, raising questions about its exact origins and possible consequences. Advanced sensors on the James Webb Telescope have detected unusual activity deep in the center of Andromeda. The signal returned to scientists shows results that differ significantly from previous observations, fascinating scientists around the world. The signal indicates important processes taking place in the galaxy, which may be related to this massive black hole or previously undiscovered phenomena. One of the latest discoveries suggests that Andromeda's mass may be much larger than that of the Milky Way, changing our understanding of the size of both galaxies. The James Webb Telescope has also provided detailed images and spectra of Andromeda that reveal the formation of new stars and their chemical composition. This new information is crucial to understanding galactic evolution and the possible conditions for life. In addition, the telescope data shows increased activity in the core of the active Andromeda Galaxy. This ultimately affected the surrounding environment and is expected to shape its future structure. In addition, by studying the effect of gravity on the stars of Andromeda, scientists can gain insight into the distribution of mysterious dark matter in the galaxy. Understanding dark matter and its effect on the universe is one of humanity's greatest mysteries. Recent successes of the James Webb Telescope have sparked various studies around the world as scientists investigate the mysteries of Andromeda. As more information becomes public, we now know more about galaxies beyond our own. So what have we learned about the Andromeda Galaxy through our many studies? Andromeda has shown remarkable properties that distinguish it from other galaxies scattered throughout the universe. Its size alone is striking, with recent tests showing a diameter of about 220,000 light-years. This number makes it one of the largest galaxies in the local group, even larger than the Milky Way. That enormous scope contributes to its mass, which is estimated to be 1 trillion stars, surpassing our galaxy in star count. Scientists also find galaxy building fascinating. Unlike a typical spiral galaxy, Andromeda has a bulging center and a dense core surrounded by rings of dust and gas. This is undoubtedly fertile ground for continued star formation. Such features suggest a dynamic galaxy created by ongoing processes shaping its evolution. Among its many features, one of particular interest is its core. It is characterized by a double emission peak, indicating the presence of a supermassive black hole similar to, but different from, the Milky Way. This provides important information about the nature and function of these massive material-consuming holes. The Andromeda Galaxy is also surrounded by a halo of stellar debris that includes stars, planets, and globular clusters hundreds of thousands of light-years across. This halo tells a fascinating story about the galaxy's unique origins and history. The 460 globular clusters found in Andromeda also provide insight into very early star formation and provide a clear explanation of cluster formation and the early evolution of the galaxy. Putting together the Andromeda puzzle, astronomers are one step closer to understanding the cosmic significance of dark matter. But one question remains. How do they explain its mysterious nature and role in galactic dynamics? Andromeda has another unique feature: its satellite galaxies. The structure of its halo consists of more than 20 smaller galaxies, some of which are currently in the process of shedding their stars and gas. This process involves a large galaxy pulling and destroying neighboring small galaxies, showing the dynamic nature of cosmic evolution and describing how galaxies grow and interact with each other over time. What is the future for the Andromeda Galaxy? Its shape and path fascinate not only astronomers, but also those who want to understand the cosmos. The ability to transition from a spiral galaxy to a ring galaxy is an essential part of Andromeda's evolution. Evidence points to a number of events that could lead to rare combinations, probably from galactic collisions or close interactions with other galaxies. If Andromeda is indeed moving in this direction, it means that it has experienced many interactions with other galaxies since its birth. Ultimately, Andromeda's fate depends on the upcoming collision with the Milky Way. According to models, this collision is estimated to occur in about 4 billion years. As a result of such a collision, a new galaxy is born from these two massive celestial bodies.
Although catastrophic, the collision is a natural part of galactic evolution. However, due to the great distance between the galaxies, this galactic collision does not pose an immediate threat. After the collision, both galaxies are significantly restructured, forming new shapes and compositions. The interaction of these gases and dust triggers new rounds of star formation, creating a spectacular view of the sky as the merging objects flash brightly. Ultimately, this cosmic event leads to the formation of a single elliptical galaxy. Such a collision is not unique, as the universe has a long history of similar events. However, our direct participation makes it a very interesting event for us. In addition, the expected collision of supermassive black holes at the core of two galaxies adds to the mystery of this celestial figure. This shows the complex and profound nature of cosmic evolution. Fusion explosions are predicted to cause more matter to engulf the black hole, releasing massive amounts of radiation. This process provides important information about how galaxies move during their lifetimes and how black holes affect this evolution. However, this raises a crucial question. What will happen to our solar system after this merger? Far from complete destruction, the direction and conditions of the solar system can be greatly altered. That means possible orbital changes or even ejection from the recently merged galaxy. To understand this mechanism, scientists study similar events elsewhere and contextualize the possible fate of our galaxy. It is important to note that interstellar collisions are rare in space due to the great distances between galaxies. However, gravitational changes can disturb the stable orbits of stars, causing some stars, including our Sun, to change orbits. Such a change could disrupt the climate of this planet point, One of the most important changes that humans can experience is moving closer or further away from the sun. This can cause either a warming or cooling effect. A warmer climate could cause melting and sea level rise, while a colder climate could trigger another ice age. In addition, the geometry of such an installation can prevent the level of radiation reaching the Earth and create even more difficult conditions to ionescence. The merger of the Andromeda and Milky Way galaxies illustrates the complex relationship between the celestial bodies. As the black holes in both galaxies converge over time, their gravitational effect could increase the flow of high-energy particles potentially reaching Earth. Ultimately, this creates a new galaxy with different properties and various opportunities for future exploration. This extraordinary interaction of factors highlights the dynamic interaction of forces that shape the universe. This increases the importance of continuing the search for knowledge and monitoring of the unfolding cosmic events. The signals detected by the James Webb Space Telescope mark the beginning of a new chapter in our understanding of the universe. The chapter is full of anticipation, curiosity, and the possibility of amazing discoveries.